Hello everyone, my name is Amir Soleimani and I'm a PhD student at University of Amsterdam. I'm going to present our paper entitled BERT for Evidence Retrieval and Claim Verification. Let me first explain the problem. The task is to verify a claim based on a set of documents. In our case, they are Wikipedia introductory passages. I can say that it is a little similar to textual entailment or natural language inference, but the difference is that you need to first find the evidence sentences supporting or rejecting the claim, and then do the claim verification. We use fewer dataset that meet the expectation of such problem. It has 185K claims labeled as supported, refuted, or not enough information. It has also 50K Wikipedia pages containing potential evidence sentences. You see some samples in the figure. For example, Roman Atwood is a content creator. So we need to first find the evidence sentences in our Wikipedia documents and then classify the claim based on the retrieved evidence. The figure shows our system architecture. We have a claim and Wikipedia passages. The first step is to find the documents containing the evidence or relevant information. Actually, we filter out irrelevant pages. The second step is evidence retrieval or finding sentences. And the last step is the verification step. Based on the retrieved sentences, we classify the claim as supported, refuted, or not enough information. For the first one, we use UKP Athens method, which is the state-of-the-art method in the fever document retrieval, and it has actually the recall of 93%. And for the next two steps, we propose to use BERT model as evidence retrieval and claim verification. We use two main approaches in IR, pointwise and pairwise approaches. We do so to compare these methods for these tasks and to see which one is the best. Also, to the best of my knowledge, it is the first time that BERT is used in a pairwise framework. For the first one, we use regular cross entropy, and hinge loss and rank net loss are compared for the second approach. You see the pointwise model here. We have a potential evidence sentence and a claim, and then the BERT model is trained with a cross entropy loss on top. And this is the pairwise model. We have a pair of sample, positive and negative, and two BERT models with shared parameters, and we use rank net or hinge loss on top. In this work, we propose to use hard negative mining. In the dataset, we only have positive pairs or evidence sentences. For example, Jack was born in Amsterdam. Consider this as an evidence. And for the claim, we have Jack was born in the Netherlands. So this is a true claim. But what can we do for the negative pairs or non-evidence sentences? All the Wikipedia sentences except the evidence sentence one can be negative samples. So a regular method would be a random selection of negative samples or random negative mining. But the problem is that samples can be very easy and trivial. For example, ECIR will be an open online event, and the previous claim, Jack was born in the Netherlands. This is a false sample, but you see that it is very easy and trivial. We propose to use hard negative mining or H&M to find more challenging negative samples, and we use online H&M. It is fast and effective, and it doesn't make the training much longer. Consider that we want to train our BERT model with the batch size of 32 samples. We first evaluate the model with 128 samples without calculating the gradient, and then sort the samples by loss, and then train on the 32 hardest samples, and repeat this process again and again. And let's see the result. We show that BERT is much better than the state-of-the-art methods for evidence retrieval. Also, the pointwise method has a better performance than the rank net loss or hinge loss that we use for the pairwise method. You see that H&M helps to improve the performance in terms of precision and recall for the pairwise method significantly. Also, it keeps the performance for the pointwise method. And let's see the verification result very shortly. We show that the retrieval step matters a lot since it creates better training set for training the verification system. Also, in terms of fever score, which is the main evaluation metric for this dataset, we need not to miss the evidence sentences to have a better result. To conclude, I would like to emphasize again that using BERT improves the performance in both steps, IR and the verification step. We also showed that pointwise BERT evidence retrieval has a better performance. And finally, hard negative mining helps a lot to increase the performance. For the future, H&M can be studied more. Right now, for example, to train BERT or other methods, people use random samples. What would be the effect of H&M on, for example, faster training or having higher performance? Thank you so much for your time.